We rely on information every single day. We search for it online, we hear it from other people, and we also get it from scientific journals. But the real question is, what is the difference between just finding a random website online and a rigorous scientific journal? Or in other words, how come we trust those scientific journals? Well, there's a lot of reasons, and today we're going to talk about a few of them. Now, to see what the issues are with non-scientific journals or sources of information that are maybe less credible, we need to discuss bias, which is something that all of us inherently kind of have. And bias is a preconceived or pre-existing opinion about a particular matter. And bias can go both ways. Let me explain. Let's say you wanted to rank which university had the best science program. And let's say you're already a university student taking a science program. It's very possible that because you are currently taking a program, you might be biased to believe that your university is really great if you have had good experiences, or really bad if you've had really bad experiences. That's what bias is all about, that you've already made up your mind about an issue before actually taking all the factors and all the variables into consideration. So when making a decision on which university in the entire world has the best science program, you already have a little bit of a pre-existing opinion. Now, in that situation, that bias doesn't seem that harmful. But in the real world, when it comes to research and information, bias can become very, very dangerous. Because bias allows individuals to craft articles, to craft information in a way that might not be fully representative of the truth, and therefore leading to things like misinformation. So, what kinds of bias do we need to look out for when we see sources? Let's talk about research studies first. When someone is trying to study something and trying to find the answer to a particular scientific question, one of the first forms of bias they might run into is something called selection bias. Now, selection bias is what it sounds like. It's when you are biased in who you select to be a part of your study. So let's go back to the university example. Let's say you really love your science university program, and you wanted to do a study by interviewing people to see which university's science program is the best. You would be using selection bias if you specifically only interviewed people that you know enjoy their science program at your university. Because you can expect them to say, oh, our university is great, our university is the best. You already kind of know what they might answer, just given the population you've selected to interview. And so your results might say resoundingly that your university is the best. When in reality, if you had interviewed a large group of people, a lot of different people from other universities, other backgrounds, other demographics, then perhaps your data might have looked different. So selection bias is dangerous because whoever is doing the research can dictate who is a participant in that research, and then that can lead to results that might not be super accurate, which is why in a lot of scientific studies, the enrollment of participants is not hand-picked or cherry-picked by researchers. The second kind of bias comes into play when you are doing research online or trying to find information, so you're not performing a study. And this is called confirmation bias. So confirmation bias is when you are trying to only look for sources that already agree with what you believe. So let's say you have a very, very strong belief that maple trees are the best kind of tree. So you go online to see if other people agree with you. And you notice an article saying, oh, maple trees are awesome. That's the article you're most likely to click on, and it will confirm your existing bias, therefore confirmation bias. But the second part of this is that you will ignore sources that contradict your opinion. So if you see another article that says, oh, well, aspen trees are pretty good too, you're more likely to ignore that piece of information or article and be gravitated more towards the opinions that already agree with yours. So that's confirmation bias. And then the third kind of bias comes into play when you are an observer. So this can happen in a lot of situations, maybe just in day-to-day life, but also in any scientific studies. There's a broad range. And observer bias is basically that you are specifically only looking out for the things you would like to see. In other words, observer bias is a bias by the person making the observations based on what they expect to see, and therefore they end up paying more attention when the expected happens. That's what observer bias is about. And that's a very general term. And all three of these forms of bias go into the broad umbrella category of selective observation, meaning that you're trying to look for things intentionally, and that's kind of skewing your results or data or research into a particular direction. Now, what do scientific journals that get published on these kinds of, scientific journal articles, what do they do better, or what do they do differently that allows them to overcome these kinds of biases? The first thing, very simply, is called randomization. So randomization is when each participant that's a part of that research study is split into different groups at random, not selected by the actual researcher. So let's say we're doing a study about a new medication. So there's going to be one group that gets the medication and one group who does not get the medication. They will be given like a placebo or a sugar pill or a blank pill, which is supposed to do absolutely nothing. So we have a medication group and we have a placebo group or a sugar pill group. Now, if the researcher was able to choose, I want you to be in that group, you to be in that group, so on and so forth, there could be a form of selection bias at play, because perhaps they choose all the healthiest individuals to go into the medication group and the least healthy individuals to go into the placebo group, and maybe that will skew the results. So randomization makes sure that the researchers can't do that, that people are assigned into those groups randomly. But the second layer to this is that perhaps if people know that they're getting a medication, they'll just seem better. They feel like they're actually getting better, and that may skew the results as well. So we have something called blinding. And blinding is where the participants don't know which group they're a part of. And you can go even a step further and do something called double blinding, where not only the participants don't know what they're getting, but also the researchers don't know which participant is in which group until the very end of the study when everything is over. So randomization plays a huge role in reducing selection bias, and it plays a really huge role in making sure that the results of a study truly come from the variable that's being studied and not about who is being studied. The second kind of thing that a lot of research studies will do is repetition. And repetition is very, very important. Flukes happen and statistical anomalies happen. So repetition ensures that if we did this study again, will we get similar results? And this makes sure that there isn't overgeneralization, or that, we did it once, we don't have to do it again, we can make sure to apply this to every situation. That's not the case. Just because you were able to get results and data once does not mean that it'll always be the truth moving forwards. So repetition makes sure that we avoid that overgeneralization. Importantly, one thing about repetition is that it should be done both in same contexts and slightly different contexts. And the reason is you want to make sure that the results you had were legitimate. So those are the same context repetitions. But you want to make sure that you can also extend the knowledge and the findings you had into different scenarios. So that's why you want to repeat with slightly different changes as well. And the third thing that's important about science is the concept of deductive reasoning, which is where we take general information and we try to make specific conclusions out of them. But the thing about science is that we need to prove each source or each form of deductive reasoning we try to make. So let me give you an example. Let's say I'm going to do an initial study that shows all green apples are sour, or I should say, on average, green apples are sour. Now I have this piece of general information and I want to apply it to another specific group. And what if I now want to say all red apples are also sour? I can't simply make that deductive reasoning and that logical jump without first testing it under the scientific method. So the scientific method encourages us and pushes us to make sure that every time we try to make some kind of logical assumption or deductive reasoning, that we have to prove those kinds of data and studies and findings. So at the end of the day, one thing that's important to note is that the scientific study is not perfect. You cannot eliminate 100% of bias. But there is something that's important, and that is it contains far less bias than your average source online, because there's a lot of rigorous processes that go into the scientific method. First of all, other than everything that we just mentioned, we also have things like peer review, where other people edit, look at, read over, reanalyze all the data and information on those studies. Another thing that happens a lot is that these scientific articles or scientific journals will actually list the weaknesses and the biases in their study methods. And they'll say, look, here are some things we could have improved on. Here are some things to look out for. Please take our results with a slight grain of salt, but here are results nonetheless. So the admitting of biases and admitting that the study is not perfect allows for readers to actually get a fully informed view of what the study is trying to show. So at the end of the day, be careful with the sources you look at, but we can trust scientific journals because scientific journals go through such rigorous processes and make sure that they try to mitigate and minimize bias in as many ways as possible. So the next time you're searching online for any kinds of new information, make sure, can you recognize these forms of bias? Can you point out where the studies or the information might not be perfect? Try and see for yourself and use these tips and tricks in your everyday life. Thanks for watching.